All right, good morning. It's 8 o'clock, so we'll go ahead and get started. So just like the last time we did this, what I'll do, I'll cover a lot of the material from the course. We'll also talk about the assignment that you have coming up due Tuesday night, and then we'll open it up for any kind of questions and answer session that you may want to conduct. Okay, so first thing we'll start off with is talking about inheritance. And this also has a lot to do with your assignment. So while we're talking about inheritance, I'll also be doing up an example that is somewhat similar to what your actual assignment is, so that it can probably give you a good starting point, or at least allow you to check what you're doing so far in your assignment to kind of see if you're on the right track. Hopefully you've already started the assignment before now, but if not, you still have a couple days. But so let's go ahead and get started with inheritance. So what is inheritance? Inheritance is this concept of what we call base classes. They can also be called a superclass, and derived classes. Now, what does that look like? Well, think about it as going from something general to something more specialized. For example, if we talk about pets, let's think about pets. So let's say we had a class called pets, right? What is a more specialized kind of pet? Well, a dog is more specialized than a pet. It's talking about a specific kind of pet, right? We also have a cat. A cat is also a specialized type of pet, right? It's no longer general purpose. So I wish I had some kind of drawing diagram up here, but just think about a general base class like a pet and more specialized subclasses of like dog or like cat. And like I said, we'll do an example here in a minute. Actually, our example would be with cars. But as I start going through the example, you'll see more of what I'm talking about. So you can think about your base class as providing the basic functionality that would apply to anything of that type. So for example, if we had a base class of type pets, maybe it has a method called eat, right? Because all pets eat, no matter what kind of pet it is, all pets will eat. So maybe there's a method in pets that says eat, right? But then when we think about our specialized base class, or excuse me, our specialized subclasses, like if we have dog, since dog is a type of pet, it will also have that eat method. But what else can a dog do that's more specialized than a general pet? Well, a dog could dig, right? A dog may dig in the ground. So a dog could have a method that's called dig, because a dog can dig, but just a generalized pet doesn't dig. So that's why it would be in the subclass dog, but not in the superclass or the base class of pet. But enough about pets and cats and dogs. Let's get into the example with cars, and we will see how this kind of pays off and what happens. Okay, so start off here with our main class and our main method, nothing there new to Java. Let's make a new method called car. Excuse me, a new class called car. Like I said, this is going to be somewhat similar to what you have to do for your assignment. So as I'm going over this, I'm actually also going over things related to the assignment. So let's say we have a car. So what are some properties about a car? What are some variables about a car? Well, we can have a string that says the make of the car, right? And it's a Toyota, Ford, Chevy, Subaru, whatever, right? We can have the make of the car. What else does a car have? We have the year it was made, the year it was manufactured, right? What else is there about a car? The mileage on a car. And that's enough for now. So these can be variables that describe a car, right? So now let's make up some methods that apply to all cars, right? So first we need the constructor, right? For the constructor, we'll give it the make, the year, and the mileage, and then let's save those in the variables. So there's the constructor for a car. We just pass in the parameters that describe the car, and then we save those here in the class variables. Okay, what else can we do with the car? Well, let's be able to print it out. Let's do the toString method so that if we want to print out a car, we print out the information about the car, all right? So we'll say the make is the make plus, what do we got? We got the year is the year, and then we have, excuse me, the mileage, right? Let's just got mileage, and then we'll return that string. Okay, so we're just making up a string that's saying the make, the year, and the mileage of a car, right? This is pretty simple. Let's just make a car to make sure this is working right. So here in our main method, let's make a car. And we'll say the make is a Toyota. The year is 2010, and the mileage is 100,000 miles. Okay. And then let's just print it out. Car.toString. And that should just print out our car. Nothing new yet, just some basic functionalities. Print it out, run it. It's compiling. And there we go. There's the car. It's a Toyota 2010 with this 100,000 mileage. Okay. So, and actually, let's figure out what the price should be. Okay. Let's have a method to get the, actually, let's have another variable that says what the price is. Private, it'll be a float, the price of the car. So how can we compute the price of a car? What's the price of a car? Let's just say if it's a basic car, it costs $1. Well, $1,000. All right. So let's append onto here also the price. PRICE plus this dot price. There we go. So now let's run it, and we'll just see that our printout also includes the price now. And there you go. The price is $1,000. Okay. So those are some basic things about a car, right? The make, the year, the mileage, and the price. Okay. But now let's think about more specialized types of cars. Well, the two I like to use for my example is we can have a gas-powered car, but we can also have an electric car. Actually, we'll use 3 examples. You have a gas-powered car. Actually, let's stick with the 2 to keep it simple. Gas-powered car and an electric car, right? They're both still cars, but they are a more specialized kind of car, right? One runs on gas, one runs on electricity. They both still have these properties. They both still have a make, a year, a mileage, and a price. So those are still common. Even if it's an electric car, it still has those properties. But an electric car has some additional properties, right? It has the battery power left, right? And a gas-powered car may have how many gallons of gas it has left in the tank, right? So why would we not put, well, we could put private battery charge here. This is probably better as a float. Private and float gallons in tank, right? So if we did that, we could kind of cover an electric car and a gas-powered car within just the car class. But if it's an electric car, then this variable is a waste, right? If it's a gas-powered car, it doesn't have a battery, so why would we care about the battery charge, right? That's why we would like to subclass a car into 2 different classes. So let's make a new class called, we'll just call it gas car, right? What we can do, we use the word extends car. What that means, it means the gas car, it is a car, but it has some additional functionality in it. So what additional variables would a gas car have? Well, I just said one of them, private float gas in tank. Say how many gallons of gas is left in the gas tank. We could also have the miles per gallon it can travel, right? Those are additional things that apply to a gas car that don't apply to a car in general, right? Those are the only two I can think of off the top of my head. So let's just go with those. So in your gas car, you also need methods as well. So you also need a constructor, so a gas car. So what properties do we need to give a gas car? Well, we need to tell it how much gas is in the tank, and we need to tell it what is the miles per gallon, right? So we can save those, gas in tank, miles per gallon, MPG. But there's something we're missing here. As you can tell by the red squiggly line, there's something missing here. Like I said, a gas car, it is a car. And what do we need to make a car? To make a car, we need all of these variables. We need to tell the car what its make, what its year, and what its mileage is. But here in a gas car, we're not telling it that yet, but we must tell the base class, we must tell it these things to make the base class. So let's also give these variables to a gas car. But now we have to do an additional step here, and it's called using the keyword super. What this does, it is calling the constructor of the superclass. The superclass is this right here. It's what you're extending. So since a gas car is extending a car, it means car is the superclass, and we must call the constructor of the superclass. And the constructor is this right here. This is the constructor of the superclass. So we have to call the constructor and give it the variables it expects. It expects the make, the year, and the mileage. So let's call the super constructor like this, and let's give it the make, the year, and the mileage. There we go. No more squiggly line. So now what we have created a more specialized kind of car that also has gas and tank and miles per gallon. Now, in this class, we don't see a variable for year, we don't see a variable for mileage, we don't see a variable for price, but they still exist in a gas car. That's because the variables that exist in the base class also exist in this subclass, even though we don't explicitly spell them out. So what can we do with a gas car? Well, for a gas car, actually, let's take one step back. So as I said, a gas car, it is a car, right? So let's make a gas car. Let's delete those. So let's make a gas car, equals a new gas car. What do we got to give it? We got to give it the make, Jeep. We got to give it the year, 2020. We got to give it the mileage, 1,000 miles. How much gas is in the tank? It's got 10 gallons in the tank right now, and it can go 25 miles per gallon. Okay, and then let's print out the Jeep and see what happens. So let's run it. So there we go. We have a Jeep with this year, this mileage, and this price. Well, what happened to the how much gas is in the tank and the miles per gallon? What's happening here is, since gas car, it is a car, that means it has all of these variables. It also has all of the methods of the base class. So when we do this car.string, it's going to look in gas car. Is there a toString method here? There is not a toString method, so it'll go to the superclass and look for the toString method, and there is a toString method, and so this is the one it'll run. So what could we do to make sure we also print out the gas in the tank and the miles per gallon? Well, here in gas car, we make the two-string method. And here we can print out whatever we want. I mean, this isn't useful, but it's useful for the example. So now when we print it, excuse me, now when we run it, it prints this out. And that's because it says, okay, it's a gas car. Let me see if there's a two-string in the gas car. There is a two-string, so this is just what I do. The better thing to do is to print out all the information associated with the car, right? So we want to print out the make, the year, the mileage, and the price. We still want to print those out, and we want to print out this gas in the tank and the miles per gallon. So let's print out all these and then add on the miles per gallon. What we can do, we can call super.toString. And what is that going to do? It's going to call the toString method of the superclass. The superclass is car. So it'll call this and it'll run this method. And what happens in this method, it makes a string with all that information and it returns to us the string, right? So now S is a string containing all that information. So let's just add on to it the gas in tank and add on to it, what else? The miles per gallon. And then we'll return that string back to the main method so I can print it out. So now let's run it. And there we go. We have make, year, mileage, price, gas in tank, and the miles per gallon, just like we want. All right. So what I've done here is I've used inheritance. I've made a new class that extends a superclass. It adds additional functionality to it. It's adding the gas in tank, it's adding the miles per gallon. And then it's also extended or overridden one of the methods. What I mean by overridden one of the methods, it looks in the base class. There's already a method toString, but we can make the same method with the same name and do different stuff with it. And what we've done with it, we've also added on the gas intake, the miles per gallon. So let's also make an electric car. We'll do this one a lot faster. Electric car. It will extend car. So what does electric car have? It has both battery charge remaining, and it has private float in miles remaining on charge. And that's kind of a long variable name. But think of the battery charge remaining. Think about it's like 10% full, 50% full, 80% full, something like that. And the miles remaining is just saying, okay, if I have 80% charge, I can go 50 more miles or something, right? So here's the constructor for electric car. We still need the make, the year, and the mileage, but we also need, let's just call it battery level here, and we'll call it miles remaining here. Actually, let's take off miles remaining and you'll see why here in a second. So we call the superclass, just like we did in gas car, we called the superclass make, year, and mileage. Electric car is extending a car, so we call it the super constructor, make, year, and mileage. But now we also have the battery charge remaining, say battery level. And then we also need to figure out the miles remaining on charge, right? Let's just use a mathematical formula for that, just to do something different. We'll say that depends on the battery level remaining times, I don't know, 1,000. I'm not good with electric cars, I don't think. But what this will do, let's say the battery charge remaining is 50%, it's 0.5. So this would give us 0.5 times 1,000. It's still go 500 miles. It's probably too far. Let's put 250. We also want to override the toString method. And just like we did here with the gas car where we use the super class, we also want to do it here. But here in the electric car, we don't have gas in the tank. We have the battery level, right? Battery, yeah. And we also have miles remaining. Miles remaining on charge. There we go. All right, let's go back to our main method. Oh, excuse me, yeah, main. All right, let's keep that car, and then also let's make an electric car. I have an e-car is an electric car. So it'll be a Ford, it'll be a 2015. It has 50,000 miles on it. It has a 25% charge left on it. And there we go. And then let's e-car print out. Let's see what happens. So there we go. We have our Jeep, which is our gas car. So it says Jeep, the year, mileage, the price, the gas in the tank, and the miles per gallon. And here's our electric car. The make, the year, the mileage, the price, the battery level, and the amount of miles left that it can drive on that charge. Okay. So that's the base class, and this is two subclasses of it that extend it, and that's the basics of inheritance. Another thing I want to talk, well, two more things I want to talk about inheritance is, just like with the gas car, we added additional properties, additional variables, we can add additional methods. So what's something that a gas car can do that you don't do with a general car or you don't do with an electric car? We can fill up the gas tank of a gas car, right? So if we fill up the gas tank, we're going to add to the gas in the tank. Let's say it can hold 30 gallons. I don't know. Let's say that's whenever we fill it up to 30 gallons. Okay. So we could fill up the gas tank. Does it make sense for a general car? No, because a general car, it could be an electric car, right? And you can't fill up the gas tank in an electric car. So it makes sense to have this method here in this subclass to fill up the gas tank. Likewise, in an electric car, we could charge battery. If we charge the battery, then the battery charge remaining goes to 100%. But when that battery charge changed, it also changes how many miles we can go, right? So when an electric car, when we charge the battery goes to 100%, but it also changes how many miles left we can go, right? So let's go back here to main. So let's start out with the gas car. So we have the car, the Jeep, blah, blah, blah. It has 10 gallons, whatever. Let's fill up the gas tank and print it again. Likewise, with our electric car, let's charge the battery and then we'll print it out again. There we go. So we're making a car with this many gallons. We're going to print it out. We're going to fill up the gas tank. We're going to print it out again so we can see the change. We'll have the electric car. We'll print it out. We'll charge the battery and then we'll print it out again. Okay, let's run it. There we go. There's our Jeep. Note it has 10 gallons of gas. We filled it up. Now it has 30 gallons of gas. Here's our electric car. It started out with this amount of charge, and it can go that many miles. We charged the battery, so now the battery level is at 100%, and we can go that many miles. Okay. Now let's go on to the next step. So since car is the superclass, is the base class for gas car and electric car, like I said, that means an electric car, it is a car with more functionality. A gas car is a car just with more functionality. So here in our main, let's get rid of some of this stuff. Actually, let's bring back just the gas, or yeah, let's just work with just the gas right now. Just right there. Okay, so we have a gas car, right? And the variable type is gas car. We can also use the base class because a gas car is a car. So our base class, our variable can be of the base class. The car can be a gas car. The car 2, can also be an electric car. Put this stuff back in here. Was that all right? Yeah. And then let's print it out. System.out.println ecar toString. Oops. That's not ecar anymore. It's car2.toString. There we go. So instead, we did have gas car here, but now we can just generalize it to just car. We did have electric car here, but now we can generalize it to just car. Now, why is that useful? And this actually kind of gets into another part of what your assignment's asking you to do. You know, this kind of relates to your assignment where the car is like the gift in the assignment, and the gas car and the electric car are kind of like the fruit basket and the sweets basket in your assignment, right? Something else your assignment needs an order system, right? Instead of order system, we're going to have a dealership, right? Where we're going to, we have cars and we're going to sell cars, right? So let's take this stuff out here. Let's just make a dealership, new dealership. And we'll do some more stuff with it in a second. So with a dealership, what do we have in a dealership? We have a bunch of cars, right? So let's make a list of cars. Let's make the constructor of a dealership. Okay. Let's make the list. Oops. There we go. So a dealership has all these cars. Right now, there's no cars in the array. So let's add some cars to the array. But what's important to note here is this type is car. It's not electric car. It's not gas car. It's just car. And what that means is we can put in this list, we can put a car, we can put an electric car, or we can put a gas car into this one single list. And that's because electric car and gas car are subclasses of car. Otherwise, we'd have to have a list for gas cars, and we would have to have a list for electric cars. And that's harder to keep track of, that's harder to manage. So what we can do, we can just have a single list of cars, and we can put both kind of cars in there. And that's because the electric car and the gas car, they are cars, just with more functionality. So with this, let's add some cars. We can put a gas car in there. It's called a Toyota. What else did it want? It wants the year, 2000, mileage, 1, 2, 3, 4, 5, gas in tank 1, 2, and miles per gallon 2, 3. Just some random numbers. Let's add an electric. Yeah, let's add an electric car. We'll do 4 cars in all. For example, electric car. electric car. So electric car, we need to put in the battery level 25%. This electric car, yeah, we don't want them all to name the same. So it'll be a Toyota, then it'll be a Ford, year 2001, mileage 23456, battery level 25%. We'll have another gas car that is a Volkswagen, year 2010, mileage 34567, has 18 and miles per gallon is 30. You know, we're just making up some cars here. So for the last car, what else is there? Toyota Ford, electric Jeep, this year 2020, mileage 45678, and the battery level is at 0.35%. Okay. So what have we done here? So in our main, we're creating a dealership called the dealership constructor. And the dealership constructor, we are, creating the list of cars, and then we're adding 4 cars into that list. And even though it's a gas car, even though it's an electric car, it can still go into this list of type car. And that's because a gas car and an electric car, they are both cars. It is the superclass of these two variables. All right. So let's also do a toString with the dealership. And what we'll do whenever we print out the dealership, then we'll just print out a list of all the cars. Okay. So let's make a string S. Then we'll loop over all the cars in the list. So this is stuff. This is basicer stuff, but also stuff I covered in the last video, how to do this loop and these lists. So say the string is equal to that right there, and then we'll return the string. So what have I done here? I've made a blank string. We're going to loop over all the cars in the list, and each time we're going to add on to that string the information for that car, and then we'll do a new line. And then we'll return that string so that here in main, we can print out the dealership. And we should see all those cars listed, excuse me, in the dealership. And there we go. We print out the dealership and it prints out all this information. Okay. So just like in your order system for your assignment, we have a dealership that has a list of the cars. For your assignment, it should probably be a list of gifts. I don't know, throwing you a bone there. All right, let's go another step further. So with a car, they also have a VIN number, right? So let's store the VIN number for a car. And the reason why I'm putting it in the base class is because a VIN, it will apply to any kind of car. It applies to a gas car and it applies to an electric car. So since it applies to both of them, you want to put it in the base class. Let's modify our toString to make sure it includes the VIN. We already modified the constructor to take the VIN. So that means we got to give it the VIN here. All right. The base class, when it calls the superclass, has to give it the VIN. That means in the dealership, when we make the cars, the first parameter now needs to be the VIN. We'll call it AA. I know real VINs are a lot longer than this, but I don't want to type in 25 character long VINs. All right, so there we go. So now let's print it out.
And there we go. We have the characters with all these VINs. This VIN could be like the ID that you need to have for your gift class, right? So we have all these VINs, right? So what else do you need to do with your assignment? You need to be able to, so let's go back to the dealership. Let's take out these default cars and run it. That way it starts out with no cars, right? So when I run it, nothing's printed out because we don't have any cars yet, right? So for a dealership, we need to be able to add a car to the dealership. Void, let's add a car. And how we do it? We'll add it to the cars list. Okay, easy enough. So let's go into main. We have our dealership. Let's add a car to the dealership. Just be an electric car. Oh, great. Make Jeep, year 2020, mileage 1234, battery level 0.56%, whatever. Okay. Run it, and there we go. That's the one car in our dealership. Let's add 2 cars to our dealership. Make the second one a gas car. Toyota 2018, mileage 2345. And then how much gas is there's 5 gallons left in the tank, and it gets 23 miles per gallon. Let's run that. There we go. We have these 2 cars at our dealership. This is kind of like how you need to add gifts into your order system. Now, for your assignment, you do need to get input from the keyboard. You know, the user needs to type in the ID. Is it a sweets basket? Is it a fruit basket? And so on and so forth. So I could do some user input here. I could have the user type in what the VIN, the make, the year, the mileage, etc. I can have them type that in. I'm not going to go through getting the user input in my example. It would extend it out and I wouldn't have time to do other things. Plus, getting user input is pretty basic stuff. You should know how to do that at this point. All right, so there's adding a cars, right? Change that to BB. There we go. So a couple things you have to look out for your assignment is, can you have 2 gifts with the same ID? You're not supposed to. You're supposed to not allow that. Just like we can't have 2 cars with the same VIN, right? All VINs are unique. Right now, it takes it with no problem, right? But how can we prevent 2 cars with the same VIN from being added? Well, let's look at our dealership. When we add a car to the dealership, we need to check, does that VIN already exist? So actually, let's just make another method. It'll get a car, get car with VIN, get car by VIN. I like that better. We'll give it the VIN. What this will do, this will look through all of my cars and see if any of them has that VIN number. We can loop through all the cars. Now, if this car, excuse me, we need to get what the VIN is of the car. So the car needs a method to get the VIN. Public string get VIN. Return the stop VIN. Now, we could have just made this variable public, but we talked about last time why that's really bad and about encapsulation. So we'll just have a method to get the VIN of the car. So now we'll say, if this car's VIN, that gets the VIN of the car, if it equals to the VIN I passed in, then I can return the car. If it gets to the end, I can return null. So what's happening here? So we have this method. It's going to return a car. We have to give it the VIN that we're looking for. So this, we will loop over all the cars in our list. And then we'll say, if that car's VIN is equal to the VIN I gave it as a parameter, then I'm going to return the car because that car has a matching VIN. Now, if I loop through all of these and I never return, meaning I never found that VIN number, then I'm going to return null. And that's just kind of representing there is no car with that VIN number. So how can we use that? We can use it in our add car. We can say if get cars by VIN, car.vin equals null, else do something else. So what's happening here? I'm going to call our method get car by VIN. I'm going to give it that VIN number of the car we're trying to add. If it returns null, what does that mean? If it returns null, then there is no existing car with that VIN number. If there is no car with that existing VIN number, then we can add the car. If there is a car with that existing VIN number, sorry, bud, a car with that VIN already exists, and we don't add it. Let's go back to our dealership. Let's go back to our main. Let's make them different VIN numbers to see. If they're different VIN numbers, everything is fine, right? If they are the same VIN number, we get, sorry, bud, a car with that VIN already exists. And then we still get the Jeep because the Jeep was added first. So that one's still in there with the VIN. But when we tried to add the second one, it's sorry, bud, the VIN with that car with that VIN already exists. Okay. So that's how we can look at doing an add. One of the other things you have to do with your assignment, you have to look up a gift or get a gift by its ID and print it out, right? Well, we kind of already made that, get car by VIN. So let's imagine we just have this one car. Now let's get the car by VIN. Dealership dot get car by VIN. We will get the AA. Instead of just printing out the whole dealership, we're going to print out the car. So we made a dealership. We added this car to it with that VIN. Now we're going to get the car by the VIN number, and then we're just going to print out that car. There we go. Works fine. What if we want to find a car that does not, excuse me, if we want to look up a car by this VIN number, but that does not exist, what happens? We're actually going to crash our program. Oh, well, it prints out null. It's probably not what you want to do. You probably don't want to print out null. So what we can do, if car is equal to null, some out.println, car does not exist. Else we'll print out the car. So what's happening here? We're going to look up the car. We're looking for the car with this ID, this VIN. If the car is null, then we're just going to print out it does not exist. Else it's going to print out the car. Let's run it. It prints out car does not exist. Why? We only have one car. That's AA. We're looking up another. We want to look up a car that is BB. There is no BB car. So it returns null. Car does not exist. And of course, if we look up a valid car, it does exist. And there it is. So that's how you can use like the find method or looking up a gift in your assignment. So what can we do with this car now that we have it? Let's say we drove it some more miles, right? So look, initially it has 1, 2, 3, 4 miles, but let's say we want to drive the car 10 more miles, right? So first, let's just print out the car, right? Let's drive it 10 more miles and then print it out again. So how do we drive it? Well, we can't access the miles variable to change it. And why can't we access the miles variable? We can't access it because it is private. But what we can do, we can have a method that will let us modify the number of miles driven. Actually, let's just make a method called drive. And when we drive a car, it changes the number of miles. So we have miles plus equals what? Well, let's give it as a parameter the number of miles that we drove. So what's happening here? If we call the drive method, we give it as a parameter how many miles we drove, and it's just going to add that on to our mileage. So here in our main, we can drive the car. We want to drive it 100 miles and then print it out again. So we run it. We get the Jeep how it starts out with 1234 miles. And now we drove it 100 miles, and now we print it out, and you can see the mileage changed by 100. This is like in your assignment when you have to look up a gift and you have to modify something on the gift. Right? With your gift, I think it's something like you can tell if it has citrus fruit or not, or you can tell if it has nuts or not. Whatever the case is. But this is how we did it with a car. We have a dealership, which is like your ordering system. We added a car to it, which is like adding a gift to your order system. We're looking up a car by its VIN, which is like looking up a gift by its ID. And we're modifying something on the car. We're changing the number of miles it has on it. But this is like, changing how many fruits are in your fruit basket, or changing the size of your basket, right? So that's covering a lot of what kind of is in your assignment. Let me bring it up again, see if there's any other little part I want to touch on it. I want to make sure I covered everything with your assignment. Creation, fruits, order a gift, change a gift, and display a gift. We have done that. We have ordered a gift. Right here, that's like ordering a gift. We have changed a gift. This is how we have changed the gift. And display a gift. That's what we've done right here. We have gotten the gift by its ID, and then we're displaying the gift by just printing it out. Of course, we did it with cars, right? So that's inheritance. That's subclasses, superclasses. This is really a lot of what you have to do for your assignment. Just with your assignment, you have to add in some things like getting user input, displaying a menu, and things like that, which is similar to what you had to do for the last assignment anyway. So you should be able to carry a lot forward from your last assignment for the menuing and things like that. All right, let me go on to talking about recursion. All right, I'm not going to delete any of these other classes. I'm going to delete the stuff out of main. Actually, let's just comment it out in case I need it later. So another topic is recursion. So what is recursion? Recursion is where a function will call itself to do work. The most classic example is the Fibonacci sequence, right? What is the Fibonacci sequence? I think it starts out at 1. It's like 1, 1, 2, 3, 5, 8, 19, 11, 12, 13, 21, etc. And how do we get that for the Fibonacci sequence? We get that is the first two values are always 1. It's just a definition of the sequence. But then the next value is the sum of the previous two values. Okay, actually, let's not do Fibonacci. It's more complicated. Let's do factorial. So what is 5 factorial? Right? What is that? That is equal to 5 times 4 times 3 times 2 times 1. Right? What is 4 factorial? Is 4 times 3 times 2 times 1. Oops. What is 6 factorial? And so on. 6 times 5 times 4 times 3 times 2 times 1. Right? We can actually do a little bit of substitution here, right? So let's look at 4 factorial. 4 factorial is 4 times 3 times 2 times 1, right? That's the same thing as right here, right? 4 times 3 times 2 times 1. 4 times 3 times 2 times 1 is 4 factorial. So we can replace this with 4 factorial, right? So 5 factorial is equal to 5 times 4 factorial. Let's go all the way down to 1. Oh, okay. We got 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. 1 factorial is equal to 1. And that's kind of where it stops, all the way at 1. Right? So with 1 factorial being 1, we can replace this with 1 factorial. 2 times 1 is 2 factorial. 3 times 2 times 1 is 3 factorial. And then 5 times 4 times 3 times 2 times 1 is 5 factorial. Okay? So how does this relate to recursion? So in order to calculate 3 factorial, I first need to calculate 2 factorial. To calculate 2 factorial, I first need to calculate 1 factorial. To calculate 1 factorial, well, that's just 1. It's not an additional computation. It's just the value 1. So let's make a method to compute the factorial of a number, and we have to use recursion to do it. You don't have to. There are other ways, but it's a good candidate to use recursion. So what does a recursive method look like? Well, let's just make it public static int factorial int number. So what this will do, we're going to compute the factorial of this number, and we will return that as an integer, right? So how do you compute it? Well, look at this formula right here. So for 6 factorial, it's 6 times 5 factorial, right? Same all the way through. But let's talk about the most basic one. If the number is 1, then the answer is 1. So let's start with that. If the number is equal to 1, then return 1. Actually, let's start if the number is less than 1, it's actually undefined. So let's just return 0 on that. So if the number is 1, then we're just going to return 1. That's what they call kind of the base case for recursion. That means this is the point where we no longer call our own function. Every recursive function must have a base case to where it does not call itself anymore. And for factorial, this is it. This is the base case, where if the number is 1, we just return 1. We don't call factorial anymore. All right. So if it doesn't, if it matches this, this is actually kind of like an error. Actually, let's make an exception. invalid number. All right. So if you try to call factorial with a number less than 1, it actually doesn't make sense. So we'll just throw the exception. Okay. Now, if the number equals the 1, it's 1. So what about if the number does not match one of those? If it's not one of those, then what is it? So if it were 6 factorial, then it would be 6 times 5 factorial. So what it is, it's the number times the factorial of the previous number. All right. Let me comment this out so it doesn't think it's code. So you can see here, inside of the factorial method, we are calling the factorial method again, just this time with a different number. Right? So let's put it so that we can see what's happening. We'll just say computing factorial for this number so that we can see what's going on. Let's run this. Let's just call value equals the factorial of 3. System.out.println 3. Squiggly is just for the exception. There we go. All right. So we're going to compute the factorial of 3 and then print out 3. Let's look at the printout to figure out what's going on. So computing the factorial for 3, computing the factorial for 2, and computing the factorial for 1. And the ultimate answer we get back is 3. I don't think that's right, is it? 3 times 2. That should be 6. What did I do wrong here? Oh, we're just printing out 3. I want to print out the value. Oh, I must have lost my mind there. Okay, now let's print out. The answer is 6. Yeah, the answer is 6. So why are we, so even though we're only computing factorial for 3, why are we getting all these additional printouts? So we're computing factorial for 3. So here, number is 3. So we will print out computing the factorial for 3. 3 is not less than 1. 3 is not equal to 1. So we will do this. So we'll get 3. So it's computing 3 times factorial of 3 minus 1. So it's computing that, right? So we call factorial of 2. When we call factorial of 2, it goes back into the function saying, okay, the number is now 2. So we print out computing the factorial for 2. 2 is not less than 1. 2 is not equal to 1. So we'll go here. So then we're going to return 2 times 1 factorial, right? Because the number is now 2. The factorial is 2, is the factorial of 1. Okay, so now the number, we call the method, the number here is 1. So we'll say computing the factorial for 1. 1 is not less than 1. 1 is equal to 1. So we're just going to return 1. And that's all there is to recursion. Recursion is calling your own method, meaning inside of factorial, we call factorial to do further computations, right? The key is you must always have kind of the base class. If you don't have the base class, what's going to happen? Let's take out this base class. We crash. Why do we crash? Because we're trying to compute the factorial for 3, which is fine. We compute the factorial for 2, which is fine. We compute the factorial for 1, which is fine. But then we're trying to compute the factorial for 0, and you can't. There is no factorial for 0. There is no factorial for negative numbers. Okay, so that's why you need that base class. so that you stop. At some point, you have to stop recursively calling your own function. And that's what we did here. I mean, this one does because it throws the exception, right? The invalid number. So eventually it got there. You know, what happens if we don't even have that? We don't even do that check. Yeah, it's no longer an if else. Let's just have this. If the only thing we are doing is just printing that out, and we're not checking for a base class, we get another kind of error, right? So look, you're trying to compute the factorial for all of these negative numbers. And eventually what you're going to get is like a Stack Overflow exception. There we go. Is a Stack Overflow error. That means you've called recursively, you've called the function too many times. Because there's some additional memory requirements that have to happen when you do this recursion. Nothing you have to worry about yourself, but the Java virtual machine, there's some additional memory things that go on in the background. And this is basically saying you ran out of memory, you ran out of stacked memory to do this. So that's why it's always important to include these base cases in here. There we go. So that's recursion, calling your own function to do some kind of computation. And I mean, not all computations need this. You know, if you were calculating the area of a rectangle, that's just length times width, right? There's no point in using recursion in that sense. But for factorial, the very definition of factorial is recursive in nature. The very definition of the Fibonacci sequence is also recursive in nature. And I could have done an example, but the factorial is actually simpler to look at. So that's recursion. All right. Last thing we're going to do, and we'll just leave that function in there. We'll comment out this code in case I need to come back to it. Let's talk about GUIs. GUIs, graphical user interfaces, are one of the harder things to do. I got about 30 minutes, but I'm going to go through this more quickly. You don't need to do GUI for this upcoming assignment, so I will have another chance to talk to you about GUIs before you actually have to do an assignment for them. But a GUI is a graphical user interface. It's buttons and windows and things like that. So let's make a quick GUI. In Java, a window is called a JFrame. And we can make a new JFrame. Let's give it a title, My Frame. Okay. That's just a window, just like any window, like your web browser is a window, right? This program I'm using right here is a window, right? So what can you do with a window? You can set how big it is. How big do we want our window to be? Let's say it's 256 by 256. That's how big it is. You can set its position, set location. They call it set location. But what position on the screen do we want it? Let's put it at 100, 100 on the screen. And then let's just show it. And we show it with set visible to true. So this is going to create a window with this title that's this size, and it's at that location. Let's run it. And there we go. There's the window. With just those 4 lines of code, I've made a window on my screen, and I can interact with it. I can drag it around. I can minimize it. I can maximize it. I can close it. There we go. And that's showing a window on your screen. So where's some other things we want to do? So besides a frame, let's just say we want like a pop-up message box. We have what we call a J option pane. And if you just want a pop-up message, you can call what we call show message dialog. And what you have to give it what the parent is. We're going to say null, meaning it doesn't have a parent. If we wanted to, we could make this frame the parent of it. And actually, let's do that. So we'll make this frame the parent of that pop-up message. We also need to give the message. This is my message and the title of the pop-up box. My title. So this is dialogue. What am I doing wrong? Object message title. Oh yeah, and then the message type. Was it J option pane? Oh, forgot what this is. Some error or something. Yep. I think that might be it. Let's try that. So let's run this. There we go. So there's my frame that I did, but then here is this message dialog that just pops up. Just a little pop-up dialog box that has an OK button, it has a close button. There you go. This is my message. This is my message. My title, and I said it's an error message. You can put other things here like warning message. What that really does is just change what icon is here. An error message just has like the stop sign with the X in it message. And I click OK and make it go away. So that's just a little pop-up box you can do. We can also get input from the user with another option pane. That's called show input dialog. Here we also make that the parent. And we'll just have input your name. As we see here, the show input dialog, it actually returns a string. So what will happen here, it'll show up a little pop-up box and it'll let you type something into it. And here, my prompt is going to be input your name. And so whatever you type in is going to be stored in the string. And then what I'll do, I can use that string for whatever I want. Let's just change this message to this. So what's going to happen here? You know, I make my window, I have a pop-up box that lets me type something in. Whatever I type in will be stored in this S variable. And then in the next pop-up box, I'm going to say hello, and then whatever S is. Let's run it. There we go. Here's that input dialog. What's my name? My name is Dan. I hit OK. It says, hello, Dan. That's one way we can get input in a GUI. Okay. So this is a window. Like I said, I can resize and do whatever I want. But I want to put things on this window. You know, maybe I want to draw a picture. Maybe I want to display some text. Maybe I want to have additional buttons, right? We're going to go through this quickly in about 5 minutes. Like I said, I have future videos that we can go over GUIs in more depth. Has a concept of what we call a J panel. A J panel is just an area of your window. J panel. Oops, a new J panel. We'll do this quickly. For a panel, we want to make, we can do frame, set, set content panel. Set content pane to be this panel. When we do that, we're just telling the frame, we're telling the window that this contains, this is what we want to show on that window. So with the panel, we can add different stuff to it. First, we need to set a layout. We'll do a box layout. What a box layout is, it's just a vertical, that should be right. Oh, hold on 1 second. Don't want to waste too much time in this. We'll just leave it at that. I'll cover that in the next video. We're almost out of time. Let's just say I want to add a button on here. Let's make a J button. new J button. We'll say it says click me, and then we'll add it to that panel. The button at the end will show visible after everything's done. So what have we done here? We make the window. We're saying this panel is the content of that window. We're going to add a button onto that panel, and then we're going to show the window. Let's run this. It should have a button that says click me. And it does. It has a button that says click me. Now, when I click it, nothing happens. And why not? We haven't told Java what to do whenever I click it. So let's quickly do that. So with button, we can have what we call an add a listener, add action listener, new action listener. So what happens, and you see it filled out some of this stuff for us. So we're saying button, we're going to add an action listener to it. This is the action listener, and this is the method action perform. This method will automatically be called by Java. Java will call this for us whenever we click the button. So whenever we click the button, let's just do a pop-up dialog. Hello there. Let's just leave it at that. Keep it simple. Let's run this. Now, as you can see, I have a button. When I click it, there's the pop-up box. Hello there. I can click it again. I can click it again. And it does the same code over and over and over. That is the very, very basic overview of a GUI. Like I said, I'll have more time when we do the next video before you actually have to do any assignment with it. But just for now, know that JFrame is a window. A panel is just an area of your window. It can contain subcomponents. We're telling the window this panel is what I want to be in the window. I'm making a button. I'm telling it what to do when the button is clicked. And then I'm adding that button to this panel. And the panel is what we added to the window. And then we show the window. Click me. There we go. And we'll leave the rest of the time to questions. There are a lot more things besides buttons you can put on there. You can put input fields, you can put password fields, you can put images, you can put combo boxes, you can put list boxes. There are tons and tons of components besides just buttons, but buttons are really the quickest and the easiest one to show. So that's the quick version of what's going on with the GUI, and we'll cover GUIs in more detail the next time we have these sessions. Okay, so we have about 15 minutes left. And if you have any questions, I'll go ahead and take them now. Doesn't seem to be any yet. I will stick online about 2 more minutes. Okay, I got a message. I don't have any specific questions on this material. If you have any questions on any other Java question, I'll be happy for that as well. If you have any questions on anything else in the class or any other assignment or concept. If not, I'll stick around about 2 more minutes. If nothing after that, then we'll go ahead and end it. I am getting this video posted sometime in a little while, and I'll get that link sent out in email. So standing by about 2 more minutes. Or actually, since I have about 15 minutes left and it doesn't look like there's any more specific questions, I'll spend the next few minutes touching on a few more things for a GUI. So like I said, there's other things besides buttons you can put on here. You have what we call a J text field. Call it TF, a new, not a formatted text field. I just want it to be a J text field. Was it? There we go. And we'll add that onto our panel. Text field. So what does that look like so far? And then you'll see what we can do with the text field. Oh, it's really tiny. I think I got to set the size for it as well. TF.set size. Yeah. Let's say it's 256 by 64. Oh man, why is that not showing up like that? We do need a layout manager. Panel.set layout, new flow layout. There we go. That should be fine. What this set layout does, it lets Java automatically decide where on the form that item should be put. So when we do panel.add this text field, that means it's allowing this layout to automatically decide where to put it and how big to make it. Why is that still super little? Give me 1 second. Layout. Oh yeah, forgot to pack. Oops. Oh, so frame.pack. There we go. Forgot about the frame.pack. We're gonna make sure it looks right. Oh, of course this is going wrong right when I'm doing this. All right. We're gonna call it for now. Just keep in mind that's really small. I don't remember why, right off the top of my head, why it's not showing the text field to be the full size that we want it to be. That's fine. It will be fully covered in the next video that we do for GUIs. Just see that you can do other things besides buttons. This one, it's a text field. What we could do here, I'll probably do this and then we'll go text field, string text columns. Yeah. This is the default text. I think that should make it larger. Yeah, there we go. So there you go. We have this input. This is the default text. So what can we do with it? So just like here, when after we click the button, we say hello there. Well, let's say hello there, and whatever they typed in, we say the text field dot get text. I think it is. Yep. So tf.getText, what that'll do, it'll look at this text field and it will get a string that's whatever you typed in. Let's run it. So instead of this, let's just type in Dan. Let's click the button. There we go. Hello there, Dan Steffi. This is actually pretty important for not the assignment you have due this coming Tuesday, but a couple weeks from now, you do have a GUI assignment to where you have to do some either distance conversions and temperature conversions and things like that, where you have to put in a value, you have to click a button, it'll do some kind of conversion, and then it'll print out what the answer is. That's kind of what this looks like for the next assignment. Like I said, we'll have a future Zoom where we cover all that. Okay, so that's it for today. I'll go ahead and wrap it up, and I will get this video posted online here in a little bit. All right. Have a good day.